So on today's video, I think, so let me preface by saying I am not a lobe designer. I do not design cam lobes. We pay people to do that. But, as I go, and obviously, in the grand scheme of the cam grinding world, we are, or I am, very young in the deal. We've been grinding cams for 8 years now. Yeah, 8 years. And, there's just a lot to it. There's a lot of stuff going on. And, I try my best to educate myself. But a lot of this stuff, especially with the actual design of the lobe, people just don't share that information. Even our lobe designers, and we've got a couple. I mean, they'll tell me stuff, but they're not going to sit down for a month and just learn me all about it. They're busy. Everybody's busy. So as we go, and as I look at stuff and understand more stuff, I start seeing patterns of what's a problem and maybe what's not a problem. And why is it a problem in this application, but it's not really a problem in this other application. So a long time ago, we used to see a certain cam come in that needed to be reground. The lobe was hurt. And we would see the same cam or the same grind a lot of times. And so I just had a lobe made years ago. I had a lobe made for this cam to be able to regrind it, because a lot of them, the lobe's just tracked up a little bit. It's not like a major deal. It just needs maybe 10, 15 thousandths off the surface, and it's fine again. The heat treat's still good, so forth. So I hadn't never really paid it any attention before, but again, as we progress, we just looking at stuff, looking at the data. What's the data telling us? So I run the cam on good load in the doctor before we reground it. And then I ground it yesterday. And so I brought it back to the cam doctor this morning and just run it again to verify the profile. And so after I done it, I was looking at I'm not trying to make this super complicated, but I'm just trying to unpack what's going on, so maybe it'll slightly demystify some of this stuff. So you've got velocity, acceleration, and jerk. So most people just talk about velocity. Velocity is the rate of change of lift per degree. So how much is the degrees of duration changing per thousandths of lift on the cam? So with flat tappet stuff, there's a maximum, with a given tappet diameter, there's a maximum velocity. We can't move any faster than X with this size tappet. But with a roller, it's a little different, because you've got pressure angles and curvature, and there's some other stuff going on that's more than we're going to talk about in this video. But so both of these lobes, the original lobe and the one we had designed, are almost identical. They're almost identical. And so it really fits well. We don't have to take much off. It cleans right up when we regrind them. So I run them. I've got all 4 lobes. Intake and exhaust original, intake and exhaust what we had designed. And, you know, everything looked fine, nothing, you know, and it was almost just an accident. But I pulled up the jerk curve and I was really, I mean, there's a good bit of difference. And so acceleration is, velocity is the first deal. And then the derivative of acceleration, velocity, I'm sorry, is acceleration. And then the derivative of acceleration is jerk. So we talk about the jerk curve. So the jerk curve is, you know, the valve train gurus say, you know, a bad jerk curve will upset the valve spring. So in really high-end race applications with, you know, super stiff push rods, solid lift stuff, big spring pressure, big massive rocker arms, you know, they really work hard to keep the jerk curve super smooth. You know, we don't want peaks and valleys and all of that. So I'm gonna spin you around and I'm gonna show you the difference in the jerk curve of the two lobes. All right, so this line here is the jerk curve, and then this is the lift curve. And so let me get the curve. So can you see the curve? So obviously it correlates. So this jerk here is in the opening ramp. Then obviously this jerk over here is in the closing ramp. And all of this right here is in the peak over the nose. So, and this is two lobes and two jerk curves stacked on top of one another. So I'll turn it on and off so you can see the difference. So I'm gonna turn off the original design, the original lobe that come on the cam from the factory. So if you see how smooth this opening jerk curve is on what we had designed, and then I'm going to turn back on the original. See how spiky that is? So you see all those spikes, and it's the same way if you look right here over the nose. I'm going to turn the original off. All right, so that's what we got. And you see how much higher the peaks go. So, and it's not quite as bad over here, but it's still, you know, I mean, you can still see it. So I thought that was pretty interesting myself, because like I say, I hadn't actually looked at it. I mean, I look at this stuff a lot, but I hadn't grafted two lobes over the top of one another and really seen how much difference that there can be in two seemingly identical designs. And then we can we can add, so this is the velocity curve, and you can see how the velocity slowly increases and then, you know, decreases over the nose. and then you can really see how it lays back in from the main event and sets it down at the seat. And you can see how much difference. And again, this is a hydraulic profile. So with hydraulic profiles, you'll see how much more visually aggressive the opening is than the closing, because with a hydraulic lifter, you know, basically you've got all of that oil cushion, so you don't need this big massive ramp like you do with a solid design. So that makes life a little easier, you know, but again, you know, once you get to the end of the profile, you got to set it down to keep the valve from bouncing off the seat. And you know, this is just stuff. I mean, I had no idea. You know, people talk about ramps. We hear about ramps all the time, and most people don't even know what a ramp is. You know, maybe we'll go over here to the whiteboard. I know there's a guy on my channel. He makes fun of my whiteboard all the time. So we'll go over here to the whiteboard and we'll do some ramp drawing. All right. So, and again, I'm not a load designer, and I'm not an artist either. So, you know, the ramp kind of, I mean, I know this is super, like maybe cheese ball, but think about the on-ramp at the interstate. So we can't, you know, when you leave, you know, in a race, you know, when you leave, you know, it's violent, especially like a trans brake or whatever. We don't want that. We want a gentle, we got to give it time. So if you're going whatever, so the ramp may look something like this, right? So when you accelerate, and it's the same way, so we got acceleration. So when you accelerate, you want to smoothly accelerate. Now you can come off the seat faster than you can set down, but you know, for just general purposes, we're just going to talk about smoothly accelerating. So from 0 to 20 miles an hour, if you will, you know, we want to smoothly accelerate, but then from 20 to 40, we can accelerate much faster from 20 to 40 or 20 to 60. So we got to get it, you know, we got to get it off the seat, off of the base circle. You know, here's the base circle. We got to get it off of this base circle because it's not moving. There's zero acceleration. We got to get it off the base circle. And then we might have a constant velocity area that is, you know, the rate of change is not excessive, but we're doing that 0 to 20 deal here. And then once we get that done, now we can get on with the rat killing and get this thing moving up the main event. And then possibly, just like you've seen the jerk at the nose radius, let me make sure you can see that. So let me bring it down here. So we got this nose radius happening, and you know, maybe some designs, maybe not, slow down just before the nose radius, because you don't want the lifter to just, you know, go to the moon, which they will, and we see that a lot. Let me adjust this a little bit. So we don't want the lifter to leave the lobe, and then when we come down, you know, we got the same deal again. We gotta slow it down, and like I said, on the hydraulic stuff, because of the cushion, you don't need much happening here. It's just a gradual from the base circle to gradual up. But on this side, you know, we got to set it down nice. And so anyway, I just thought that was kind of, man, that's horrible. It looks like a kindergartner done that drawing. I apologize. But I just thought that was, you know, interesting, that two designs with the exact same duration, the exact same lift, the 20 and the 50 and the 200 numbers were all within a quarter of a degree, a half a degree. So, and to see the jerk, and we're talking about that jerk curve that you've seen is 4, 5 decimal places. So it's still super small. And why does it not matter in your street, small block, LS, whatever? Because the valve train, nobody puts a big enough push rod. Everybody runs, most people run more spring pressure than you need. So in these low RPM episodes where you got a super flexy valve train with lifters bleeding to death because you got too much valve spring pressure, you just never know. You don't know that it's a bad or good design because the valve is not seeing the camshaft. It's not seeing the camshaft. You can look at any Spintron data and you'll see, you know, we can take the cam doctor report. This thing is whatever, 250 at 50. Run it on the Spintron and it's 238 at 50 on the Spintron. And the higher the RPM goes, the smaller the cam gets. And, you know, if you got not enough spring pressure, or a really flexible push rod, you know, it'll, like we was talking about, over the nose of the cam, it'll just pole vault it. So you'll end up on paper with a bigger cam. You know, that 250 at 50 might be 260 or 265 because it's leaving the cam lobe and it's out there just kind of hanging around in the atmosphere till it, and you see it, well, we see it a lot with stuff that's out of control. When it comes over the nose and the lifter pounds into the closing side flank, we'll see a lot of damage on the closing side flank. And generally speaking, that's all from the valve float. And a lot of times it's floating, but it's consistent. So, you know, Joe Racer doesn't even know that it's floating because the float is consistent. It just doesn't go out of control. So, so then, you know, when it's time to freshen the motor, they pull the cam out and it's all beat up on the closing flank. And then, you know, they'll send it in, hey man, can you regrind this, fix it, whatever. And so, you know, we see that a lot. And so, but it's important to not have a bad lobe design. And how do you know? Well, I mean, it's hard to know always. You know, buy cams from reputable companies, not, you know, Amazon and a white box. You know, and it's better if you just work with your engine builder, and obviously, you know, they've probably been using somebody for a long time and had good results, and some stuff's better than other stuff. Some lobes are aggressive and some lobes are not so aggressive, and from, I mean, you know, there's a place for everything in that world, but what we see mostly is, if you open and close the valves in the right place, that's way more important than do you have the super latest and greatest valve spring murdering lobe that company X offers. And, you know, it's funny how it's come full circle. You know, I see companies now offering lobes that are, you know, super gentle. And I've been saying that, you know, well, when we started, you know, I told the lobe designer, I'm like, man, give me some stuff set on kill. I want it to move the valve, you know. And he's like, okay, but, you know, it's probably not gonna work out good. I'm like, you know, I'll worry about that. And, you know, in some of the dirt track stuff we were doing early on, you know, engine builders called me, hey man, we beat the locks out, we beat the retainers up, the end of the valves tore up. So we trashed all of that. It don't work. Most applications, you just can't make the valve train rigid enough to use it. You know, we're not pro stock. I mean, in pro stock, you can do that crap because they're changing parts, you know, every 2 passes or whatever. So, but in this endurance stuff, street stuff, you just cannot have that set on kill stuff. You just can't, not, and expect it to live. So we come off all that nonsense. Everything we got now is, you know, just good quality designs, no crazy, you know, kill stuff, and it makes power. The super stuff. Again, in some applications, it may make a little more power, but those applications are rare. In your general stuff, it's not gonna. It'll usually make less power and cost you a lot more money for the parts you're killing. So keep that in mind. My stuff is not special, so I'm not saying that, you know, X company's stuff is garbage and my stuff is better. That is not what I'm saying. I'm just saying that I thought it was interesting, the difference in the jerk curve. I'm not saying their jerk curve is creating a problem. I'm just saying that I thought it was very interesting, the difference in the 2 jerk curves for a given duration and lift. So this is just, you know, I'm just sharing information. I like to see data and I like to share data because, as we all know, you know, there's so much confusion out there about this stuff. As I was confused before we started the cam business. You know, they stuff that I didn't know, that I didn't even know that I didn't know. So, and probably 8 years from now, when we do another video about this stuff, everything I just said may be mud. So anyway, thank you. We appreciate you. Like, share, subscribe. It really helps. We almost at 3,000 subscribers. I didn't ever think that would happen. That's awesome. We appreciate you. Check out the website if you need anything, cam stuff. Send me a message on the website. Happy to help you if I can. Y'all have a great day.